This is the mini lesson for 5.1. So today I'm going to teach you how to model the multiplication and division of integers because you can use models to help build your conceptual understanding. You're then going to develop rules for multiplying and dividing integers that will not require the use of models, knowing that dividing by 0 is considered undefined. Okay, so if we look at the visual summary, we're going to fill in this table. So when I look at this, the description for this means 3 groups of 5. And so an addition sentence for that, think of multiplication as repeated addition. It means 5 plus 5 plus 5. It's 3 groups of 5, which adds up to 15. If I want to talk about a number line model for this, I'm not going to put in every number, so I'm just going to put in 5, 10, and 15. So again, I would start at 0 and I'd go to 5. That's my first group of 5. From there, I go over 5 more for my second group of 5. And from there, I go over 5 again for my third group of 5 to show that I would end at 15. Okay, with the 2 colored counter models, here's my workspace, and I have 3 groups of 5. So there's 1 group, 2 groups, 3 groups, which I can again see gives me a positive 15. Okay, when I look at this second one, this means then 3 groups of negative 5. 3 groups of negative 5. So that would mean negative 5 plus negative 5 plus negative 5, which I know when I add negatives, when the sign's the same, my answer stays the same, and I add their absolute values. So again, I would get negative 15, but let's do a visual on what that means. I'm going to put 0 way down here on the number line because I know I'm moving in a negative direction 3 times. So I'm going to put negative 5 in here, negative 10, and negative 15. So my first group of negative 5 goes from 0 to negative 5. My second group starts at negative 5 and goes in a negative direction 5 more. My third group goes negative 5 more, and I see that I do in fact end at negative 15. 2 colored counter model, I have 3 groups of negative 5. So there's 1 group of negative 5, 2 groups of negative 5, 3 groups of negative 5, and I can see how that also gets me negative 15. When I have this negative in the front, this means the opposite of 3 groups of 5. The opposite of 3 groups of 5. So the opposite of 3 groups of 5 would mean 3 groups of negative 5, which I see that's the exact same as this. So I get negative 15. So my model is going to be the exact same. So it's the same model as the 3 times negative 5. And this model will be the same as 3 times negative 5. So I'm not going to redraw those. Here again, this means the opposite of 3 groups of negative 5. So I'm going to write that in words first. The opposite of 3 groups of negative 5. Well, if I don't have 3 groups of negative 5, if I have the opposite, I have 3 groups of 5, which I see is just like this first one. So this model would be the exact same as 3 times 5 as with this model. So in every case here, my rules for multiplying. We know that when we have a positive times a positive, I get a positive. But now what I see is a negative times a negative was the exact same as that. So a negative times a negative also gives me a positive. I see that a positive times a negative, so that's like this example, gave me a negative answer. And I saw that a negative times a positive also gave me a negative. It didn't matter which absolute value was greater. It's just when I had one of each, I always ended up with a negative answer. And in every single case, to get the number portion, I just had to multiply the absolute values. So that takes care of my division or multiplication rules. Now I want to look at division, and for division, I'm going to look at some fact families. So right away, I'm going to take ones that we know already. So I know that 5 times 4 is 20. And so I can use the commutative property and do 4 times 5, and I still get 20. And then we can do the fact family backwards. So I could say 20 divided by 4 gives me 5, and 20 divided by 5 gives me 4. So 20 divided by 4 is 5, 20 divided by 5 is 4. I'm going to use the same concept to create a fact family for negative 5 times 4. So up above, we already said a negative times a positive. Negative times a positive is a negative. And I multiply the absolute values. 5 times 4, 20. So I can use the commutative property and do 4 times negative 5. That's going to also be negative 20. I could start with negative 20. I can divide it by 4. And I know that I will need to get negative 5 for an answer if this is a fact family. And I could start with that negative 20. And I can divide it by the negative 5. And I should get 4. We're going to do the same here with negative times a negative. So we already determined that a negative times a negative is a positive, and we multiply the absolute values. So 5 times 4 is 20. So again, commutative property, I can do negative 4 times negative 5, and I know that that has to give me 20. So now I can take the answer, 20, divided by the negative 4, and that has to give me back this negative 5. And I could take the answer, and I could divide it by the negative 5, and it has to give me back my negative 4. So now I want to look for rules for division. So I already know that when I have a positive divided by a positive, I get a positive. Let's look to see what happens when we take a negative divided by a negative. So I see that happening right here. Negative divided by a negative, I got a positive. When I have a positive divided by a negative, let's look at what I get. Here's a positive divided by a negative, and I got a negative. And when I do a negative divided by a positive, starting with a negative divided by a positive, I get a negative. And in all cases, I divide the absolute values. So when I look at then multiplication and division as a whole, I see that their rules are exactly the same. I either multiply the absolute values or I divide the absolute values. When I have 2 negatives, I get a positive. When I have 1 of each, I get a negative. The only thing that can't happen is we cannot divide by 0. So any number divided by 0 gives me an answer called undefined. And I'm going to give you an example as to why. I'm going to take just an easy number. I'm going to take 6 divided by 0. If I were to write that this way, it's 6 divided by 0. So when we go to start to solve this, I have to ask myself, what can I put here that when I multiply it by 0, I get 6? There is nothing. No number times 0 gives me 6, because anything I multiply times 0 gives me 0. So that's why this is called undefined. Some people want to tell me it's 0, but if you think about it, if we put a 0 here, 0 times 0 would be 0. That doesn't give me 6. So this answer is always called undefined.